Okay, we're going to do the last section of notes for this unit, and it's over geometric sequencing. We've been doing arithmetic sequencing, and now we're going to do geometric. Another type is geometric sequencing. I think I just said that. If a sequence value follows a pattern by multiplying a fixed amount from one term to the next, it is referred to as a geometric. So if we're multiplying, remember arithmetic, we were adding / subtracting. A fixed amount is called the common ratio. This constant common ratio causes a sequence to create an exponential function. Now we're going to find the common ratio, just like we found a common difference. In order to find the common ratio, we take second term divided by first term. And just like with arithmetic, when I said second term and first, it doesn't matter which second and which first. I can take 27 and 81. I can take 9 and 27. I can take 3 and 9. It doesn't matter. I'm going to take 3 and 9 because they're smaller numbers. So I'm going to take 3, the second one, divide it by 9. Now when I divide here, notice it's just going to give me a fraction. So my common ratio is 1/3. Okay, do the same thing here. We're going to divide second by first. I'm going to take the first 2 this time. So I'm going to take -8, divide it by -4. That gives me a +2. That's my common ratio. So here's how I find the common ratio. The recursive formula is a formula used to find the next term of a sequence when the previous term is known. This part should look pretty familiar, same words. Now here's where it's different. This is the recursive formula for a geometric sequence. Notice you're going to find the first term. That subscript still means 1, first term. We're going to find the nth term. This still means previous term, and that's your common ratio. So this is the only thing that's actually new. That's your common ratio. And we already talked about how to find that right up here. This, of course, means your previous term, just like it did in the last with arithmetic sequencing. Okay, so nothing too surprising there. Oh my gosh, these words, you're going to go, why do I have to rewrite them again? The first, we are given, gives us 2 bits of information. The first and the pattern or rule to get any term in a sequence from the term that comes before it. Okay, so I'm going to know how to find the next term. So here we go. Here's my sequence. First I need to, and notice what I'm going to fill in. I have G sub 1, I have G sub n, G sub n minus 1. That we know. Now we're going to fill in the other information. So what's the first term? Well, that's 1. Okay? And then we have to multiply it times the common ratio. To find the ratio, I take the second term, divide it by the first term. Let's just take those. 4 divided by 2 is 2. So that's how I find it. Now, sometimes you'll see that we'll write it like this. 2 times G sub n minus 1. Okay? So you can write it either way. A lot of times we write that coefficient in front. So here we go. Let's try it. If we were in class right now, I'd divide you up and you could each try a different part. Everybody could have their own part, but I'm going to go through all of them. I'm going to do the first one, and then I'd recommend on the next 2 you do them on your own. So here we go. We're going to fill in G sub 1. G sub n is equal to G sub n minus 1 times the ratio. So my first term, 3. To find my ratio, I'm going to take these 2, just because I picked them. It doesn't matter. Pick 2. Take the furthest one, divide it by the one in front. We get a -2. So it's a -2. And again, you can rewrite that to have that -2 out in front. Both ways are fine. Okay, if you want to, pause your video and try these next 2. I'm going to keep going, but I would recommend that you try them on your own. Okay, so on B, I'm going to first find the common ratio. 10 divided by 2 is 5. So my answer is G sub 1 is equal to 2. G sub n, I'm going to write the ratio in front this time just to show you that it can be written either way. So because I'm multiplying, I can put it either place. Order doesn't matter. Okay, on C, Again, my ratio, I'm going to take these because they're smaller. 5 divided by 20, that's 1/4. Or you can, of course, use 0.25. Both will give you the right answer. So G sub 1, G sub n. And I'm trying to show you that it's what you're plugging in by using different colors. So my ratio, whoops, 0.05. My first term, 320. And did you notice with these, as it's going up, okay, you're going to have a whole number. Well, this one's weird. This one's going back and forth between positive and negative, so it's not really going up. But if I am going up, it's going to be a whole number. And if I'm going down in value, it's going to be a fraction. So times 1/4. And again, you could have put that 1/4 out in front. That's the recursive formula. Okay. Oh, we get to try some different things with recursive formula, okay? And it's kind of written a different way, and it kind of shows you in some ways how these are like functions. They are just like functions. They use the F here, so it even kind of physically looks like it. So let's go. Use a recursive to find the first 4 terms is what I'm finding. So, again, we could plug it in. So my first term is -2. If that's my first term, I'm going to take that term, the previous times -3. So I have a -2 times 3. That gives me -6. I'm going to take that times 3, and I get -18. I'm going to take that times 3, and I get a number that I need to use my calculator on. Except for I've already done these. So -54. Okay. I would recommend you do this next one on your own. Try it. Pause your video right now and try it. That's just my suggestion. Okay, so if you're not going to do that, or if you have, this is how you do it. 200 is my first one. I'm going to take it times 1/5. Oops, 1/5. So 1/5 as 200, you can use your calculator. You could also cross cancel right here. Say you could take out a 5, and you're going to have 40 left. So this is equal to 40. So far we have 200 and we have 40. Then we're going to take that times 1/5. Again, that's just dividing by 5. 5 goes into 48 times. And we have to do it one more time. Now here we can't divide, so we're just going to leave it as a fraction, 8/5. Those are our first 4 terms. Now remember, these continue on. These are just the first 4 of the sequence. Good. Hopefully that made sense to you. The explicit formula is used to find the nth term. And here's our formula for that. We're going to take the first term times the ratio to the n-1. This is where it's an exponential function. We're going to take it to that power. So it gets a little more fun this way. Okay, so here we go. Here's our information. We know our ratio on this was 4 divided by 2, which equals 2, because we did this on the page before, if you're wondering why I said we know this. So let's plug it in. G sub n is equal to the first term times 2 to the n-1. Okay? And we usually put this in parentheses. The reason for that is because if our ratio is negative, which you'll see later on. So that's all we have to do. We can't simplify it. We cannot multiply these two because this is to an exponent. That's all we do. It's kind of nice. So let's try some. Here we go. G sub n. Oh, the ratio, if you forgot, we can always find it again. I'm taking these two, so I get -2. First term, which was 3 times -2 to the n-1. Now that you've seen it done, go ahead and try these next 2 on your own. Make sure you're getting it. You're welcome to watch me do it, but I would pause the video and just try it on your own. R here we know is 10 divided by 2, which is 5. So we have G sub 1 is equal to the first term times the ratio to the n-1. C, you might remember, oh my gosh, no, I'm not doing that. I'm going to do 5 divided by 20, 1/4. That's our ratio. So G sub 1 is equal to our ratio. Oh, I wasn't doing what I always preach to you guys to do. We should write our formula down. G sub n is equal to G sub 1 times the ratio to the n minus 1. I should have been writing that down for every single problem. The good news on this test, you get to have a note card, so that makes it nice. Okay, so g sub n is equal to g sub 1, which is 320, times the ratio to the n minus 1. And that's the reason you want to put that ratio in parentheses. See how if you have a negative, it's going to make a difference, and then that fraction, that does make a difference. So make sure you put that ratio in parentheses, just to be sure. Okay, now we're going to use the explicit formula to find the given term. We're going to find a specific term, which is what this is explicit formula so good at. I'm going to write the explicit formula down. Okay, so we have it to refer to on both of them right there. So here we go. We want to find the 12th term. So I want to find g. Oh, well, I don't even need it for this. Look, they give it to me. That was kind of silly. Okay, so I want to find the 12th term. Remember, this n and that n mean the same thing. So 5 times negative 2 to the 12 minus 1. That's 5 times negative 2 to the 11th. We have 5 times, pull out your calculator. That's going to be a negative number. Now, this is where on your calculator you have to decide, am I going to use parentheses or not? If I take negative 2 to the 11th power and I don't have in parentheses, it's going to be fine because it's an odd number. So it doesn't really matter on this one. It's going to be odd. If it would have been even, that would make a difference. But an odd one, it's going to be negative either way. So we can take negative 2 to the 11th power. And hopefully you all remember how to do that. Let me show you what we do again. Usually, I'm going to do it just so we show good practice. I'm going to go parentheses, negative 2 parentheses. I'm going to use this button right here, that tent, to the 11th power. And I get a negative 2,048. I take that times 5. And we get negative 10,240. That is g sub 12. Okay, let's do this one over here. This is kind of in the way. Wish somebody would have been paying attention. No, we didn't know that. Okay, so we want the 6th term. So we want h sub 6. We're going to plug that into our formula. Negative 62 times 1/3 to the 6 minus 1. Negative 162 times 1/3 to the 5th. Okay, and luckily we have these awesome calculators that will do this for us. So we can take 1/3. I'm going to go ahead and put it in parentheses. I messed up. Okay, let me try it again. Parentheses, 1, 3, come back up, do that. Go to the power button right here. Go 5. And that gives us negative 162 times 1/243. I know these calculators are sophisticated enough, they could actually do that for us, but I'm going to leave it there. And now, look what that comes out to be, negative 2/3. Aren't these calculators awesome? Okay, that's geometric sequencing as far as notes. Let's look at the assignment. Recursive and explicit formulas determine if the sequence is geometric, and this is one of the things you're going to do on the test. Okay, and if it is, you need to find the common ratio. On the test, we're going to ask you this question: is it arithmetic or is it geometric? And what you always want to do is you want to see, do I have to add to get to the next term, or subtract, or do I have to multiply? Add and subtract, arithmetic, multiply, it's going to be geometric. And there's also just some sequences that have no specific, they're just weird. Okay, so you're going to look at all these, find out if you're going to add to get to the next term, if you're going to multiply to get to the next term. And what I would recommend is find the common ratio and see if that works first. And then also, if that doesn't work, look to see if you're adding, just to practice for the test. On these, use recursive and explicit formula to for the following geometrics. So recursive and explicit, just like we did on the notes, use a recursive formula. Yeah, so here you're going to find the recursive and the explicit. Here, use it to find the first 4 terms, or the recursive. Here you're going to use the explicit to find the given term. Now on this, again, your teacher will help you decide which ones you're going to be doing. And just check with your teacher if you're doing the whole, if you're doing half, if you're doing odds or evens, what you're doing. But you do want to practice these, and the answers are out in Schoology. So always check your answers to make sure you're getting it. Good. If you have any questions, you know where to find us.